Guys, this is the practice or the quiz that we took today. It's called a diagnostic test. It's counted as a quiz grade. So I'm going to try to work through this as quickly as possible. Number one says, what trig ratio is equivalent to the cosine of A? So angle A is here and angle B is here. And if you recall, these two angles are complementary. Okay? Their sum is 90. So we learned that the cosine of one of the first angle is equivalent to the sine of the other, or vice versa. So the cosine of A is equivalent to the sine of B. Okay, number two. What trig ratio is equivalent to the sine of 35? So what we do is we find the complement of 35. 35 degrees is going to be the complement of 35 degrees is defined by going 90 minus 35, all right? And 90 minus 35 is 55. And so we're going to go with the cosine of 55 because the sine of one angle, the complement of that is the cosine. All right, sine and cosine are complementary functions, and the complement of 35 is 55. Number three, it says find the length of side AB. And so I know one length of this triangle, so I cannot use Pythagorean theorem, so I have to use a trig ratio. Here's my angle. I'm looking for AB, that's my x. This is the opposite side, that's the side I cannot touch. And so I'm going to use the sine function. So the sine of 62 degrees equals the length of the opposite side over the length of the hypotenuse. Since x is on the bottom, we're going to end up dividing. So x is going to equal to 7.3 divided by the sine of 62. You enter this in the calculator exactly the way it's written, 7.3 divided by the sine of 62. Make sure your calculator is in degree mode. We get 8.26, and we're going to round that to the nearest tenth. There we go. D. Number four, find the length of side BC. First thing I do is put an x there. This is my angle relative to this position. This would be opposite. The right angle always points to the hypotenuse. The opposite side and the hypotenuse involve the sine function again. The sine of 35 equals the length of the opposite side over the length of the hypotenuse. Since x is on the top, that means we just multiply, we cross multiply. 12.4 times the sine of 35. Pick up my calculator. I type in 12.4 times the sine of 35 degrees. Close my parentheses. I get 7.11. So that is the answer. Number four, or I'm sorry, number five. In a right triangle, if the tangent of A equals 20 over 21, then what's the cosine of A? So one of the ways to handle this problem is to draw a triangle, and I'll call this A, B, and C. So the tangent equals the length of the opposite side over the hypotenuse. So this is the over the adjacent side. So 20 represents the opposite, A represents the adjacent. So this is 20 over 21. And so the issue here is I need to know the length of the hypotenuse. I don't know that because I can't find the cosine of an angle without knowing the hypotenuse, because cosine equals the length of the adjacent side over the length of the hypotenuse. So since I know two lengths on here, then I can use the Pythagorean theorem. 20 squared plus 21 squared equals c squared. This will be 400 plus 421 equals c squared. I'm going to add these two together. I get 841 equals c squared. And I use my calculator. 841, I'm going to take the square root of 841, so I use the second key. 841, enter, and I get 29 for the length of the hypotenuse. So this equals 29. Now I can find the cosine of angle A. Cosine is adjacent over hypotenuse. So that would be 21 over 29 for question number 5. number 6. Let's scroll down. Okay. Okay. On the right triangle XYZ, first thing I need is a picture. I can't think until I have a picture. And I know that I have to label this, and so I need to figure out, well, which side is which? Well, the most important one is the hypotenuse. That's always the longest. And so the longest side has to be labeled with a measurement of 10. And then the other two are important. I know that the hypotenuse is ZX. So I'm going to put my X here and my Z here. So then that means this has to be Y. So ZX is 10. So YZ is 8. And XY must be 6. Okay? So now it says, which of the following trig ratios will be 4 over 5? I want to stop for a second. In this case, even though we talk about how it doesn't matter which leg is which when we're dealing with a right triangle and putting numbers into the Pythagorean theorem, in this case, it does matter because we have specific legs that have specific measurements. So they're telling us that XY is 6 and YZ is 8, okay? So for number 6, now I can go back and answer the question. So which trig ratio would be 4 over 5? Well, there's no 4s and 5s over here, but I think I can tell that something was probably reduced. And so to get a 4 out of 5, this was reduced by 2. So this was originally 8 over 10. So that tells me I need to use these two sides. And so let's see, would the tangent work? Well, no, because tangent's opposite over adjacent, so it's not that one. Cosine of x will be adjacent over hypotenuse, so that's not going to work. The sine would be opposite over hypotenuse, 8 over 10. I think that's it. So the sine of x will equal 8 over 10, which reduces to 4 over 5. So the answer to number 6 has to be C. Number 7, we are asked to find the cosine of A. Here's A. Cosine equals adjacent over hypotenuse. So this is the adjacent side. This is the hypotenuse. So that would be 4 over 5. Number 7 is D. That would be an instance where you wouldn't have to show any work. You can just look at it and get the picture. Number 8 says solve. Solving means find all the missing measures. You guys were doing a really great job at that today in class. So obviously this is 60 degrees, so that was pretty easy. So now I need to figure out how long the other two sides are. So I'm going to go ahead and do this side here first. So I'm going to put my X there. So relative to angle, the 30-degree angle, this would be the opposite, and this would be the adjacent. And so I'm going to use the tangent function. I'm going to say the tangent of 30 equals x over 2.5. So x would equal 2.5 times the tangent of 30. All right. So let's type that in. 2.5 tan 30. Okay, so I know that the length of side AB is 1.4, so I'm just going to write that down. So AB equals 1.4. So that means I can eliminate these two. So now I'm left with C and D, so I have to find out how long AC is so that I can answer that. So I'm going to erase this for space. Well, maybe I shouldn't have erased that. I think I'm going to get that back. Okay. All right. And so I'll leave that there and I'll do the rest of it someplace else. So now I'll use a different color. So now this is my X. And so I'm going to now call this the hypotenuse because that's what it is. And this is still adjacent. So that would be the cosine of 30 degrees equals adjacent, the length of the adjacent side, which is 2.5. over the length of the hypotenuse, which is x. X is on the bottom, so I'll divide. So x equals 2.5 divided by the cosine of 30 degrees. All right, so 2.5 divided by the cosine of 30 degrees equals 2.88 or 2.9. All right, so it looks like I can eliminate C, and my correct answer is D. Number 9, this is another one where I can just look and see the sine of angle A. Sine equals opposite over hypotenuse. If this is A, this is my opposite side, this is the hypotenuse. So the sine of A equals 3 over 5. And that would make the answer C. Number 10. On triangle ABC, triangle C is a right angle. So we'll call that ABC. This is the right angle. And it says if the tangent of A is 1.1918, what is the sine of A? Well, I don't even know if it was important to have the picture for this one, but let's just go ahead and work it out. So I cannot find sine of A until I know what the measure of A is. And A is an angle. So when I'm looking for the measure of an angle, I'm going to use an inverse function. And so, anyway, this is a tangent of A equals 1.1918. So that means that the measure of angle A is equal to the inverse of the tangent of 1.1918. And then I can go back and find the sine of angle A. So I'm going to use the second key because I'm looking for the angle measure. Whenever I don't know an angle and I'm being asked to find an angle measure, then I'm going to use the inverse function. So I got 50 degrees. It's a little bit more, but we're going to round. So now I can come back here and say, all right, the sine of 50 degrees. So I'm going to draw an arrow. So the sine of 50 degrees, just typing it into my calculator, folks, is 0.7660. 7660. Good, it's D. Number 11. The length of the diagonal of a square is 15 feet. What is the perimeter of the square? I would say this is probably maybe the hardest problem on the test because there's 2 steps. It says, what is the perimeter of the square? So remember, perimeter is the distance around. Well, I can't find the distance around until I know how long all these sides are. So they gave me a hint. They told me that this diagonal here is 15 feet. So I'm going to extend my page so I can have some more space to write. And I'm going to just pull that out and separate out one of the triangles. Now, one thing that's important to remember on a square is that the diagonals bisect each other. So that means that this 90-degree angle here has been cut in half to 45. That means this one here is 45. Now take a look here. You see these radicals in the answers? So you see these 45-degree angles here? We're going to have to use what we know about special right triangles. Your favorite thing to do, isn't it? I can hear you moaning right now. So I'm going to go back over here. And what do we know about special right triangles when they're 45, 45, 90s? So we have 45, 45, 90. Make my little table. And the legs are congruent. So once I know one leg, I know the other leg, and I'm going to add all those together to get the perimeter of the square. So what's been given to me, oh, I didn't finish this, so this is going to be x radical 2. So what's been given to me in the problem? I know that this side, the hypotenuse opposite the 90-degree angle, is 15. And so that means that this equals this. You heard it. X radical 2 equals 15. So if I undo this math here and get the x by itself, then I'll be able to find the perimeter. Now the problem with this answer is that we cannot leave a radical in the denominator. So we have to rationalize the denominator. So in order to do that, I'm going to multiply the bottom and the top by the square root of 2. So this gives me x equals 15 radical 2. And the square root of 2 times the square root of 2 is the square root of 4. And the square root of 4 is 2. But remember, we have a shortcut for that, don't we? So when we're multiplying a radical times itself, the shortcut is that just equals the number under the radical, the radicand. So now I know how long the sides are. So going back to my square, yes, this is a long problem. Each side is 15 radical 2 over 2. 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 Now, there's a lot of ways to think about this, but we're just adding all these together. And so we have 15 radical 2 over 2 being added together 4 times. Guys, we can just multiply that times 4 instead of doing the same math over and over again, okay? You gotta remember to work smarter, not harder. So I just multiply 4 times 15. That gives me 60 radical 2 over 2. And 60 divided by 2 is 30, and I still have that radical 2. That was a lot of work. So if I were you, I would maybe watch this again and make sure you attempt to do this problem by yourself over and over again until you can do it without looking. Otherwise, you probably won't remember how to do it. Solve the right triangle. So we've done some of these before. So remember, to solve means to find all the missing angles. This one and all the missing sides. This angle is 47. So 90 minus 47 is 43. But that was kind of wasted time because all of these have 43. So they're all the same. So we know that this is 43 right here. Now we need to find our missing sides. Let's find our hypotenuse first. So this would be adjacent and hypotenuse, which would be the cosine function. So the cosine of 47 degrees equals to the length of the adjacent side, which is 20, over the length of the hypotenuse, which is x. I'm moving fast because there are a lot of problems. I'm trying to get this done quickly, so you can always put this on pause and replay something if you need to, okay? So anyway, x is on the bottom, so that means I'm going to switch and divide. So 20 divided by the cosine of 47 degrees is 29.3. All right, so that's the length of AB. All right, so can I eliminate anything? Oh, I sure can. I can eliminate 2 answers. So now I have to find AC to get my final answer. So that means that now this is my new x, all right? And so this is no longer, well, I'm not going to use this hypotenuse anymore. I'm going to use this, which is the opposite side. So that means I'm going to use a tangent function of 47 degrees equals the length of the opposite side over the length of the adjacent side. X is on the top, so I'm going to multiply. So x equals 20 times the tangent of 47. So 20 tangent 47 equals 21.44. And there I am. The correct answer is A. A. Number 13, another solve. So we're just doing the same process again. Now this one's interesting because we don't have any angle measures. So what we can do first is go ahead and find this missing side if you like. So that would be a leg, and this is the hypotenuse. It's a leg and a leg. So the first thing I'm going to do is 9 squared plus b squared equals 25 squared. And so this is 81 plus b squared equals, let's see, 25 squared, I believe, is 675. Yeah, I'm sorry, 625. 625. And I'm going to subtract 81 from both sides. That's an 81. Sorry about that. Let me fix that. Okay. Ran out of space. And so 625 minus 81 is going to give us 544. And so b squared equals 544. But don't forget to take the square root of both sides. Alright? So second radical 544. And that equals 23.32. 23.3. So that's the length of AC. So I can eliminate these two. Okay, so B equals 23.3. Now I can start finding some angle measures. So I really just need to find one, and then I can subtract that answer from 90 to find the other angle. So I'm going to go ahead and just use what's here. I'm going to use angle B. And so angle B is my reference angle. So this would be my adjacent side, and this, of course, is the hypotenuse. And so that will be the cosine function. So the cosine of x, I don't know. I could have used a b. All right, I used x. That's my unknown. So the cosine of x equals the length of the adjacent side over the length of the hypotenuse. So I'm looking for the angle measure. I do not know it. So that means I have to use an inverse cosine function. So remember to get that exponent there. That means that it's an inverse function. Remember, inverse is like reverse, working backwards. So I'm going to go second cosine, and then in the parentheses, I'm just going to enter 9 divided by 25. It's just easy that way. Okay, put it on. So second cosine 9 divided by 25. And I got 68.89, so we're just going to take that up to 69 degrees. And so that's the measure of angle B. So really that's all we have to do, because this is the only one that has the measure. So I'm going to stop it right there and move on to number 14. Alfonso is standing 50 feet from the base of the street light. So here's Alfonso, here's the base. So that means that distance there is 50. He sees a yellow speckled tukey bird perched on top of the street light. The angle of depression from Alfonso to the bird is 27 degrees. But remember we said that because these are parallel lines, alright, these two are parallel, that we have that Z pattern, and so that means that we have alternate interior angles. So that means that this angle down here is also 27. And the question is, how tall is a street light? So how much, how tall, how high, how far? Those questions are always telling us where to put our X, okay guys? And so if this is my angle here, then relative to my reference angle, this would be the opposite side. This would be the adjacent side. And so that tells me which function I have. And guys, you should always write your SOHCAHTOA across your paper or across the top of your paper or on each page. So it just helps to trigger your memory. For the sake of time, this is opposite over adjacent, so that's going to be a tangent function. Tangent function is the one that never involves the hypotenuse. So So the tangent of 27 degrees equals x over 50. X is on top, so I'm going to multiply 50 times the tangent of 27 degrees. So 50 tangent 27. Make sure your calculator's in degrees. So x equals 25.5. Ah, here it is, right there on my face, number 15. Deshaun and his brother Tanner are walking north. So basically what's happening is they were walking together. They were both walking together, okay? And then Tanner got the bright idea that he'll get there faster if he starts moving west a little bit. So Tanner turns 20 degrees to the west, so that 20 degrees is right here, and walks 30 meters while Deshaun keeps walking north. If Tanner and Deshaun have moved the same distance north, so they're still going to end up the same distance, vertical distance north. But the question is, how far did Deshaun walk? So we know Tanner walked 30 meters. Now, if you had to guess, I wonder who you would say walked the shortest distance. Who went the best way? Was Tanner's way shorter or Deshaun's way shorter? So take a guess real quick. Think about it. Take an educated guess. Okay, I hope you have your guess. So anyway, we're trying to figure out how far Deshaun walked, so that's where our x goes. And so if this is my reference angle, we know, of course, that the right angle points to the hypotenuse. And if you're here, then remember the side you can touch. Okay, that's not the hypotenuse, it's the adjacent side. So I've got the adjacent side and the hypotenuse, so that would be the cosine of 27 degrees equals the length of the adjacent side, which is what I'm looking for, divided by the length of the hypotenuse. Since x is on top, I'm going to multiply, so x equals 30 times the cosine is 27. So notice what I'm writing down each time. That's what I'm expecting you to write down. That shows me the setup and tells me that you know what you're doing. Okay, so if I don't see that, I would be concerned about how you're getting your answers. So I got x equals 26.7 meters. So now let's think about that. So Deshaun walked a shorter distance, and that's true. Remember, the hypotenuse is the longest side on the right triangle. So Tanner's distance had to be longer than Deshaun's, all right? So maybe there was something that Tanner wanted to see, but his choice wasn't not the shortest distance, okay? All right, so moving right along, we're on number 16. What is the measure of angle B? So this is my reference angle. That's telling me I'm here, okay? The side I cannot touch is the opposite side. The right angle points to the hypotenuse. You need to determine the trig function that deals with the opposite side and the hypotenuse. That will be the sine of B equals 12 over 15. So in order to find the measure of the angle, that means we're using an inverse function. So that means that x, or b, okay, since I used b, I'll stick with b, is going to equal to the inverse sine of 12 divided by 15. Alright, so you're going to type in second sine 12 divided by 15, enter, and I got 53 degrees. Choice A. Excellent. Number 17. A pilot takes off at an angle of elevation of 25 degrees. He climbs for 300 meters. What is his altitude? So here's this hypotenuse shows the path of the plane. Here is the angle at which he took off. So that's your angle of elevation. And at this point, after he's traveled 300 meters along that diagonal path, we want to know, well, what is his vertical height directly above the ground, okay? So that tells me where our x is. This is opposite. This is the hypotenuse. Here's my right angle pointing to the hypotenuse. And that's going to be another sine function. So the sine of 25 degrees equals the length of the opposite side over the length of the hypotenuse. X is on top. So that means to solve this, I'm going to multiply 3,000 times the sine of 25. I pick up my calculator, I type in 3,000. I don't even have to push the multiplication sign. The calculator, most calculators will know. But if you're not using a scientific calculator, or if it's different one from a TI, then you may have to do some different keystrokes, okay? All right, so I got 1,267.9 meters, which means the answer is C. Excellent, excellent. We're almost done, guys. Number 18. If triangle ABC is congruent to triangle XYZ, then which of the following statements would be true? So, you know, what I always say. Draw a picture. When you label, make sure you label in the same order. I know they're congruent. And, oops, those pictures are horrible. Now, I didn't read the whole question first. It says that angles C and Z are right angles. So, we're studying right triangle trigonometry. I don't know what I was thinking. All right. So, let's try this again and draw some right triangles. I know C and Z are the right angles, so that tells me that I can put my A here, my B here. It doesn't matter. The A and the B could be switched, right? Or could they? Yeah. So this could be A, that could be B, that could be C, and so on. But I'm going to put my X here and my Y here so that they're in the same order. And it says, which is true? So could the, it says the cosine of Y equals the sine of B. So here's angle Y, and here's angle B. Well, those angles are in the same position. So the sine and the cosines of them are not going to be equal to each other. All right? So it's not that one. It says the cosine of A equals the cosine of Y. All right, well, A and Y. Okay, well, that's not going to be true because those angles are complements of each other. All right, and the sine of A is going to be equal to the sine of X. So the sine of A and the sine of X seems like those should be equal because X and A are the same angle. And then it says that the cosine of A equals the sine of X. Well, no. So I like C, right? So this was like one of those reasoning kind of problems. And guess what? If you wanted to, you could actually put numbers in for A and B. We know C and Z are right angles, but once you pick a value for A and B, you could use the same numbers for X and Y. And guess what? You could just test out each one of these scenarios until you found one that works, okay? So there's a lot of ways you can work around some of these if you have your thinking cap on. All right, so number 19. Now this says evaluate. If it says evaluate, they just want you to punch it into the calculator. That's different from number 1 that said what is an equivalent value. That's the one that deals with the complements, okay? I got 0.9063 when I type that in. Make sure your calculator is in degrees, however. All right, number 20. Solve for A and B. Oh, here we go again. We have our special right triangles. And so this is a 30, 60, 90. So we know that the shorter leg is opposite the 30-degree angle. That's X. The longer leg is opposite the 60-degree angle. That's X radical 3. And the hypotenuse is 2X. That's just a memory, something you have to memorize, okay? So what do I know? What have I been told? Oh, that this is 6 radical 2. So that means that this equals this. X radical 3 equals 6 radical 2. Right? So I have to get X by itself, so I have to get rid of the radical 3. Typo there. Let's fix that. And whatever I do on one side, I do on the other. So x equals 6 times radical 2 over radical 3. Remember, we are not allowed to keep a radical in the denominator. And so I have to rationalize that denominator. And so this is going to give me 6 times radical 6 over radical 3 times radical 3, which is just 3, and that reduces to 2 radical 6. So I just found the length of the side opposite the 30-degree angle. All right. So I know that that would be B. So is that enough to answer the question? It's just enough to eliminate 2 of the answers. So I've got to go ahead and find A. So to find A is a hypotenuse, and a hypotenuse is 2 times whatever x is. So x is 2 radical 6. So this x is 2 radical 6. So I write that as 2 times 2 radical 6. And that gives me 4 square roots of 6. Now I can answer the question. The correct answer is C. Number 21, solve for M and N. Here we go again. All right, so to do this one, again, I do my special right triangle. So I'm out of space, so I'm just going to do it down here. Okay. So this is number 21 down here. So I have 30, 60, 90. This is x radical 3, and 2x. And then I label what I know. So this is a 30-degree angle here. So there's a 3 across from that. So I put a 3 right here. Oh, I'm so happy about this one. If you know what x is, then you're on easy street, because then all you have to do is plug and chug. So x equals 3. So this x is 3. So I just write 3 radical 3. And this x is 3 also. So this is 2 times 3, which is 6. All right. So let's see. Which one is this? So M is a hypotenuse. That's 6. Right. So I know that it's not these two. And then N is the longer leg. That's 3 radical 3. So it's this one right here. Okay. The hypotenuse of an isosceles right triangle is 7. So we have a right triangle, right? The hypotenuse is 7. So if it's isosceles, that means it has 2 congruent legs and angles. That's an indirect way of telling us that this is 45 degrees and this is 45 degrees. And so that means this is x and this is x. So I have a 45, 45, 90 triangle. So the legs are congruent, and this is going to be x radical 2. Those are the formulas you have to memorize. I know how long the hypotenuse is, so I'm going to come over here. That means x radical 2 equals 7. So x radical 2 equals 7. I have to get the x by itself. I will divide both sides by the square root of 2. So x equals 7 divided by the square root of 2. I'm not allowed to have a radical in the denominator, so I have to rationalize the denominator. I get 7 square roots of 2 over 2. And that's what they asked us to find. So, almost done, yay! I get to go home soon. I'm staying after to do this for you guys. I hope it helps. I hope you watch it. Which of the sets of the 3 side lengths do not form a right triangle? So, in other words, we don't want a squared plus b squared to equal c squared. We want the left side to not equal the right side. Now, people are asking a great question. Well, how do you know which one is the hypotenuse, which one is C? Remember, the hypotenuse is the longest side of a right triangle. And so that they were nice and they put the numbers in order. Don't always assume that they're in numerical order, but they appear to be. So this is not a fun one simply because you have to do a lot of calculator keystrokes, but it's not hard. So we're just testing each of these, and we're just going to test them in the calculator. Alright, so I just got to plug and chug. Alright, so 20 squared plus 15 squared equals 625. And 25 squared, I remember that from earlier, that equals 625. So it's not this one because that is a right triangle if they're congruent, okay? We're looking for one that does not form a right triangle. Let's see this one. 1 squared is 1, and plus 4 squared is 17. Okay, this might be promising. But once I do the work, I end up getting, I get the same thing. Because the left side for this one, here, let me erase this. So the left side is going to give me 17, and the right side is going to give me 17, because when I square the square root of 17, I get 17. So those worked. Okay, crossing my fingers and hoping that this one will work. And I'm putting the question marks here because I don't know if they're equal or not. So I don't want to write an equal sign if I don't know they're equal. So 10 squared plus 24 squared. On the left, I get 676. And then 26 squared is 676. Alright, so which one was that? Oh, that was this last one. Okay, so by the process of elimination, we know the correct answer is C. Alright, so I don't have to do that last one. And, oh, on the last two, yes. Okay, so I want to simplify these. And this problem here, I know some of you would probably start off by rationalizing the denominator on this one. But I just wouldn't do it here because radical 80 is such a big number. I would go ahead and simplify that first. So this becomes radical 15. And so we were having some trouble with breaking down the radicals. I'm going to show you a slightly different way. And some of you, I think, would actually love this way. I'm just going to keep breaking the numbers down until I just can't do it anymore, okay? So I have primes. And so when you do it this way, every time you have a pair of numbers, you represent that pair once on the outside of the radical and you would multiply them together. So I'd write 1, 2 for this pair right here, and then another 2 for this pair right here. And then I have a 5 left by itself. It goes in the radical. So this would give us 4 radical 5. So I can write this as 4 square roots of 5, and then we can rationalize the denominator. So I would multiply, ooh, wait a minute, I just saw something. I just saw a neat little trick. You could rationalize the denominator, but check this out. I can rewrite radical 15 as radical 3 times radical 5, and over 4 radical 5, and these would cancel out, and that would just leave me with radical 3 over 4. Okay? But you could just go ahead and rationalize the denominator. It would just make it a little more work. You have to go back and break it down. This one is going to be negative 2 times the square root of 18. And then 18 breaks down into radical 9 times radical 2, which is negative 2 times 3 times radical 2, which is negative 6 radical 2. And here we go. All right then, kitties. I hope you study hard. I'll try to make a video for the review, but I don't know. I started doing it. It was pretty long, and um, I just don't know if I'm going to be able to do it or not. So if you have any questions, you can send me a remind message, and I can certainly help you out that way. Okay? All right. Have a great weekend. I'll be looking for you at the football game, or hopefully I saw you at the football game if you're watching this on Sunday. And study hard. Okay? Bye-bye.